Alright, ladies and gentlemen, welcome back to the channel. This is going to be the definitive video where I get to find out, can I, using the sub rail, a current sink, and the clean and rock solid collector supply, tune in this fast stage, like I said, with all my support circuitry above and below it, not in the audio path. Let's see. So, first things first, I'm going to get the amp powered up. I need to take my capacitive multipliers output that goes to the collector there, and that's going to become, oh no, that stays there. What am I saying? That's for the collector. Sorry, no, I need to take, what am I saying? I need to take this resistor out and hook up this emitter to the collector of this 2SC3200 GR category transistor. This transistor here is a C3200, I'm pretty sure. Yeah, but the BL category, higher gain. So, soldering iron's warm. I'll just get a little jumper wire. Alright, so that's all set up. My phone died, so there's a little bit of a skip in the video there, but I've put that wire in. So we're now right to power the amp up and see what it does. So it's got, I think it's a 1K resistor that I had in here before. To tell you the truth, when I was building this thing, I did something really stupid to this current sink. Oh yeah, you know what? That reminds me. There was something that I noticed that was a bit odd about this circuit. I've got to look into that. The other current sources, when I set them up with PNP transistors, with no load, to my memory, I don't remember the LED being lit up, but with this one, the LED is lit up. But I've measured it and it's limiting current. So I'm a little bit confused there. Anyway, that's neither here nor there. I'll look into that and just double check later on, make sure that I haven't done something wrong. But let's power this up, see if it starts up for starters. Yep, it's, oh no. Wait, what? Not quite sure what happened there. So that's all good. What? Hold it up. Oh, can't do that. I'll just put a 1K resistor to ground there essentially, and just take this off for a sec. Oh no, that's not going to work either. Just take that off. So it's got a 1K path to ground. Something doesn't add up here. Hold on. Let me put this back on. Something's not right. Let me. Interesting. I think I've got something wrong with this circuit. You see, look, it's got no load on it right now, but the LED's lit up. And as we know, you guys have seen the LEDs go out. I'm sure that, unless that's happening when, no, it can't be. I might be confused, unless, no. I'm going to have to work this out. I'm going to have to pause, have a little, it could just be the way it works. It could just be me. I could just be missing something, but that certainly is not working going through a current sink. And if I put a 2.2K resistor from that to ground, it doesn't change the situation. So I think this circuit's not working right. I'm going to just pause the video and investigate this. Something is just not right about that. I don't quite get what I'm missing. I've got my ground reference going to this resistor. The other resistor goes to the base, same as the end of the LED. The cap goes in between the midpoint of the resistors and to the LED and the emitter resistor, and the emitter resistor goes to the emitter, and the collector goes to that. I don't see what is wrong, but maybe I have done something wrong. So, because it's certainly this. Because as soon as I take that out of circuit, it starts up. So what is going on here? Oh, you know what's going to suck? If it's not possible to put a current sink in the emitter path here. That's going to suck. Because, yes, putting a current source in the collector path worked. However, you get the varying Miller capacitance problem. And the only other way I can see of putting a current source on one of the transistors is to add an extra transistor like the LM2907 that's a PNP and supply the current source to its emitter and have it drive this and that drive that. But then you're adding an extra transistor into the chain, and I don't want to do that either. So let me just go and see if I can work out what's going on here off camera. Alright, I had a good think about this current source, and no, everything's actually correct. Because I was thinking about when I designed the current source, I actually had to calculate the resistors so the LED's got a fairly constant current going through it, regardless of what the transistor's base tries to draw off of it. So the LED is definitely supposed to be lit up all the time. So the thing that's making those LEDs go out must be one of my power rails collapsing because I've got the current limited supplies. So when the amp does something funny and tries to draw a whole load of current, one of the supply rails collapses. Either that, or maybe the transistor gets reverse biased or overloaded in some way. I don't know. But it's certainly not this. There's nothing wrong with this circuit. it's definitely working. So that's a problem because it seems like maybe I can't put a current sink in the emitter path. Maybe it, actually, good point, Dave. It's one way to find this out. I was just going to say maybe it creates too much of a voltage drop or something. Let's see. Let's have a look at the emitter where the power's coming in, and let's have a look at the negative rail where it goes to, and then we can actually look at the voltage difference. Like the voltage drop across this circuit is essentially what I'm trying to look at. 1.187, that's really not much. I mean, the capacitive multiplier is doing about the same thing itself. I think it's 1.2. So that transistor should still be kind of in the middle. Alright, further investigation. I'm going to have a look across, excuse the cats, across the capacitive multiplier. Well, finding that hard to believe, but okay. Can't complain. Alright. Oops. Okay, so from what I can tell, I think somehow having the emitter too high off the rail is causing this problem. What I think's happening is maybe it needs to be able to, how do I say this? Have a higher peak current than its continuous current when it goes to try and pull the negative rail into action to counteract the positive swing, to bring it into the middle. That's the only thing I can think of. I'm going to have to go and do some research into this because I could have sworn I read somewhere that putting a current source or sink or something in the emitter path was helpful. I do remember when I put it in the emitter path of the vals transistor itself, I did have a problem with that. I remember I had to keep putting the current up and up and up because it was basically the same sort of thing. It requires a strong current peak in one direction and a fairly continuous current in the other direction for it to be able to pull the amp back, and the current source was preventing that. So I've got a funny feeling it's a very similar thing that's going on. And we could prove that quickly. I could take that 1K resistor out and lower the value of it. I'm just going to try and power this up a couple of times. Alright, no. I'm at a bit of a loss here. I'm going to have to go do some more research. Oh, this sucks. I was really hoping that my 3-part solution would work, but maybe not. It seems like this one part's causing a problem. Alright, so I'm back on this. I haven't had any time to do some research per se. I have sat down on the couch and had a little bit of a think about it, that sort of thing, but I'm just going to try and work this one out myself. So what I'm going to do, what I want to rule out is that I don't have, between these two circuits, some sort of current path that's going where it shouldn't be, and that's what's causing the problem. So what I want to do is take this emitter. I'll probably have to go get a resistor for this because I probably don't have the one I need on the bench. No, one moment please. I only got the one that I desoldered there on the bench. Alright, so I'm going to put a 2K2 resistor in here, going to negative rail, but I'm going to leave everything else connected in circuit here. And then I'll just put it in between that track and the track next to it because it's a bit of a tight fit, but I can get it in there. And now let's try and power it up with this bypass, but everything's still in circuit, so it probably won't tell me too much because it's not going through the transistor. But yeah, no, that works. Okay, yeah, starts up stable as. Alright, okay, so it's definitely putting this current sink in the emitter path. Hey, does that LED go on or off when I turn it on? No, the LED does go on. Huh. Thou shalt check voltages. So, I know I measured the voltage drop on it before. Let's just do that one more time, just to be clear what we're supplying the emitter with. Well, sorry, in reference to ground, what are we supplying the emitter with? Basically what we should be supplying it with. That is odd. So the emitter actually is saying it's almost 60 volts. And the collector's saying almost it's 0 volts. Remember when I tried to put a current sink on the actual VAS transistor itself, not the beta enhanced transistor, the VAS transistor? Had the same problem, exact same problem. Oh, I can take that out. But when I lowered the resistor value so that the peak current going through it and the standing current was increased, it worked. Kind of. Started to work. Let's see if that's the case. I've taken the 1K current set resistor and replaced it for a 560 ohms, so that should be like 3 milliamps, that ballpark. You know what would help? In order to look at the offset, it would really, really be beneficial to be looking at the output. I did see that sort of stop at like 20 and then go back up. It's almost like it wanted to work then. Let's... Oh, that was in the wrong hole. No, was it? Wait. Alright. 560. I'll go get a 220 and 100. Can I ask you guys something? Just out of curiosity. For those of you that have been, mucking around with electronics since you, well, maybe not since you were as a kid like me, but for that many years, do you find yourself, you just get so used to what the ballpark value should be that you do less math and end up just grabbing 2 or 3 resistors and doing it that way? Or do you still do the math? Because when I first started out, I used to do the math and take a long time to work things out. And now, because I'm just so used to, I know the voltage, I know the current, I can work out the rough value, and I'll usually get it within, 3, 4 resistors at the most. And I was just curious, do you guys do that too? And the other trick that I pointed out about dialing in a resistance with a pot if you're too lazy to do the math. Leave in the comments how many people use that trick too. And yes, sometimes, adding a resistor in series with the pot so you don't burn the pot out if you go too far to the end and you've got too much power going through it. That's another trick as well, but leave it in the comments. I'm just curious how many people do that. All right, so that's 220. Oh no, I've gone straight for 100. Yeah. But the LED didn't light. Hold up. The LED did not light. Why is that so? Now, unless the current source is overloaded somehow. Where's my bloody 220 gone? What on earth are you? You're not 220. 270? That's 270. I know what I did. One moment, please. I grabbed a 270 ohm resistor. That'll do it. Ah, God, and the one I just grabbed has got solder on its legs, so I can't just put it in the breadboard. All right. 220. I don't know why that overloaded to the point that the LED couldn't light. Unless that transistor failed short, but it didn't. So, because there's nothing limiting the current to that really now. It's almost like it's got a 470 ohm resistor in the emitter and 100 in the collector. Basically, anything limiting the current to it is what's on its emitter and, what's on its base. No LED again. And amps running, but no LED. Have I popped my LED on my transistor? No. Actually, you know what? I just lifted the emitter and the amp is running with the emitter lifted from the rail. And the LED's gone out. Something's amiss here. Hold on. That's not... Oh, I've got no load. I can... Oh no, my transistor's popped. Okay. How on earth did that happen? That's a bit weird. I need to just think about this for a minute. Let me restart the amp with that emitter resistor. It's very interesting that it has no offset when that emitter resistor is lifted. Let me just grab a 2K2 and stick it between negative and... It seems we have found the source of the offset. Look how I knew my input stage was not causing the offset because I've got the 4 transistor current mirror, slight mismatch of 1 or 2 millivolts VB, and that's what we see here. That makes sense, but okay. Cool. All right, let me see if the amp will start up with that emitter resistor lifted. And the reason I want to know this flawlessly, if anything, better than it normally does. That's really odd. That is really freaking odd. If I take this transistor out, yeah, transistor's blown. I'll just leave that off to the side for testing. I've got more of them here. What's this, a 5551? 81268, 1268, 1268, 5551, 3200. Sorry, it gets confusing. Okay, the 5551's for that board. C3200. One sec. And then I'll have to remember to grab the right gain category as well, because I've got them in 2 different gain categories. I am the most fussy person you'll ever meet when it comes to stuff like this. I literally have 2 drawers of these transistors just in 2 gain categories because they're one of my favourite transistors. Low noise, high gain, low cop, great FT, great for input stages. So I have some lower gain ones like this. That's actually the number I was looking for. And I'll use those for current sources that aren't, say, on the collector of an amplifier, like in an emitter position. Or I'll use the high gain ones for, say, the amplifying transistor and its current source, if that makes sense. Just trying to give you guys a little bit of insight into how I choose not just the transistors, but the level of gain. Because you got to think about things, right? You don't want a transistor to have too much gain if it's in an area that A, it doesn't need too much gain, or B, gain could cause it to be prone to oscillation. You really need to think about these things, and that's why I do this. I'm not saying when I finish designing this and I release a schematic for you guys that you can't just go and make the whole thing out of these transistors. It'll work, you know? But if it can be done better, it can be done better. This transistor here, yeah, no, that'll never get made smaller. Anyway, I'm going to put this in. Wait, what? Hold on. Something's up here. Something is really up here. I don't know what the hell is going on, but I don't think these transistors are popped. Wouldn't it be funny if I've just built the circuit wrong? So red's collector, blue's the base. So it definitely goes in like that. With a load on it, does it light up? Hey. Oh yeah, it's not working, but... Wait, what? I'm losing my mind right now. And the LED's not blown because... Right? All that's going on here, 0 volts coming into that resistor. It goes to this capacitor to the rail. The LED goes from the rail to the other end of this resistor. Just forms a filtering and voltage divider network to bias the LED, and then that goes to the base of this transistor, and then that's the emitter resistor that goes back to the rail. And the base to emitter junction is swamping the LED current. Maybe I've built this current sink wrong. Hold on, I've got one here that I built and this definitely worked. So LED and resistor, yeah, to the base. Other end of the resistor with the other resistor and the capacitor, yes. Other end of that resistor to the rail, ground point. LED goes to capacitor and to the end of the resistor that goes to the emitter. That is correct. What the? I'm not going to lie, guys. I'm confused right now. I can't explain what's happening. It's like my current sync's not performing correctly. Also, I swear I had a 1K resistor here and it's just disappeared. Oh, here it is. Let me just put the 1K in and see if the LED stays on. So it's the base to emitter junction, like the LED goes to the base, right? And I guess the lower the resistance on the emitter, the more current gets pulled through the LED to the yeah, it's shunting the LED, I guess. That kind of makes sense. Maybe that's just my mess up. If I want to make that value lower, I might have to make the resistors that power the LED lower, but then power dissipation would come into things. Let's see what happens if I put this in circuit now. It draws current. You can see the LED get dimmer. It draws current, but it makes the amp go off. You know something? This circuit can't be performing the way it's supposed to. It just can't. Something's not right here. Ah, fuck. You heard that, didn't you? And I can smell it. You know what I just did? The end of that tapped. I just popped my transistor and my LED, I bet. Yep. Let's just double check the transistor, but from what I just smelled, it smelled like the transistor and the LED. You get used to these smells over the years. Oh no, not again. I'm going to have to look into that. I mean, I already did, but yeah. One transistor and one LED have just been annihilated. No, that wasn't lighting up through me. It was just the capacitor. Let's see what sort of voltage comes out of here in reference to the rail. That's the negative rail. Okay. What if I take my emitter resistor for the vals transistor, 2K2 for now, put it in the collector of the current source, and then, no. Let me disconnect this. Interesting. Goodness. I don't know what to say. I know I'm missing something. I just can't work out what. And it's doing my head in. I ain't gonna lie. I do have a bigger current sink that's already set up that I used for the vals transistor. I could bring that over here, but all that's going to prove is that it's something to do with peak current. I don't know. Maybe it's because it's too high a voltage to drop off the rail. You know what? Let me turn the sub rail on. Because the sub rail is off at the moment. I was thinking, oh, let me turn it off, but it's actually already off. So I've just turned the sub rail on. Like, it's always connected, but it's either offset by nothing or it's turned on. It's now turned on. Hey, that's a 1K resistor. Oh. I was going to say, why is the LED not lit? Yeah, see, it's just... Oh, come on. I swear there's got to be a way to get the current sink in there. Or am I thinking about this in the wrong terms? It like, going to the negative rail isn't a current sink coming from the positive rail, it's a current source. Is it something to do with the collector of this eating up what's on that? The signal? I don't get it. So I can understand putting the current source in the collector leg turns it into an amplifier basically with high gain at the point of the collector, and then the transistor's intrinsic capacitance gets multiplied, Miller multiplication. But what I don't get is if it's being used as an emitter follower and it's got, say, 2K2, 470 ohms, whatever it is, to the rail, two things are happening. The resistor's limiting current and it's providing a reference to the rail. So why, when I put a current sink there that's providing a reference to the rail and also limiting current, can I not get this to work? I'm starting to wonder if I'm somehow injecting some sort of positive voltage. No, I can't be, because I've measured it. It's negative. Blimey. I'm going to have to stop the video and just do some work on this and have a think about it, because I am kind of stuck. I ain't going to lie. Alright, so after destroying that resistor, I've done some thinking about this, and here's something I've noticed. Amp's running again with the emitter lifted. As we all know, if we just put a resistance between the emitter and ground, I could just simulate that by putting an alligator clip there. Not ground, negative rail, sorry. As you can see, amp's fine. Better with it than without it. About the same. Anyway, as soon as I... Oh, and another thing to point out, I'm just going to stick a resistor in the collector of this now PNP transistor set up as a current source, not a sink. So I've reversed LED, the cap, and polarity of the transistor. I put this in series, so no current's flowing, no change. Now, remember, with current flowing from the emitter to negative rail, amp's working, right? With current being able to flow, I'm guessing, let's see, going through a resistor. into the emitter. It's a PNP, so it's pointing in. Going out the collector. And through those two resistors. Look what happens as soon as a 0 volt reference enters that emitter. And so what I'm confused as to what's happening here is when I turn the current source I've got on now, or the current sink that I was using before, it does that. And also the LED is not lit, which is odd because I've got a high value resistor in there. Anyhow, am I somehow forming enough of a current path between the ground rail and this emitter path somehow that's upsetting something? I don't understand. Anything I can think of is I put this resistor in series. It's only 1K. Put it in series with that transistor. And take my meter and look between ground and the emitter, right? How do I even have that voltage there? That shouldn't be possible. Wait, what? One of my power supplies is turned up a bit. Oh, and I've got the sub rail, yeah, duh. Yeah, okay, that makes sense. If I turn the sub rail off. Yeah, okay, that makes a lot more sense. Alright. So that's the voltage on the emitter of the beta enhanced transistor. No resistor to negative rail, resistor to negative rail. Soon as I give a ground reference to the currently current source, I know it should be a sink, I'm going to put it back in a minute. Oh, fuck. Did I have to freaking do that again? Ah. You know what I'm like? I never pop stuff. I'm really, like, you see the crap I do. I do pop things, but it's rare. And I've just popped a bunch of shit today. I'm not having a good day for popping things. It's one of those days. Should probably taken that out the board first. Yep, I just popped that LED. And my transistor. Just make sure that wasn't oxide on the lead. It's happened before. They usually fail short. It says no component detected, so I just want to double check. No, that's gone. Alright. Let me just go get another transistor and a couple of LEDs to replace the ones that are missing here. Alright, I'm back. I'm going to set this up this time back as a current sink, the way it should. I want to see if the same phenomena still holds true. I don't need that. All right, so I'm going to hook onto the ground rail again. Put that on. Actually, no, I'll hook this up first. What I'll do is I'll put that on the collector where it goes, and I'll put that on the emitter. And 6109. Fuck. Sorry about my language. That just scares the shit out of me. I need to come up with a better solution for this. I almost just smoked my amp. I really don't want to do that. 61.9. And then overshoots. So it does. It's got something to do with that. Okay. Okay. Because it's clearly not the resistance, right? Because that's how it's supposed to run with a resistor there to the negative rail. And so I'm going to have a think about this. Maybe a 2-terminal current sink. Something else I was thinking about was, remember how when I had the 470 ohm resistor in here and the sub rail and the current source in the collector, the signal was really good, symmetrical, clipping was perfect and all that. I can't help but wondering how much of a varying Miller effect my current source in the collector will have. I mean, obviously, the lower the currents, the more the effect will be, because it will essentially have a higher resistance, which is the same as putting a higher value resistor there, which is an absolute no-no for the same reason. But I'm starting to wonder if that is a good idea, as long as the current's not set too small. But I still want to try and make this work. So let me just go do a bit of research, do a bit of thinking, see what I can come up with. All right, my apologies. I took a quick break and I know roughly where I was up to. I want to turn this into a 2-terminal current sink. So I'm going to get rid of the capacitor and the LED is going to get powered from the collector. I think that's right. In between, yeah, it has to. Yeah. Let's see what that does. Just disregard that. That's just the 3-volt sub rail. Oh, well. Sorry, I need to look at the output first for startup. Aha. Oh, no, that's not on. I was going to say for a second, I thought I cracked the code. So what have I done wrong here? 3200 positive pointing. Oh, I see what I've done wrong. The LED is in back to front. No. Hold on. Oh no, that wasn't back to front. What? What have I possibly done wrong now? Oh, I put both these resistors into the base. No. Still no luck. One resistor? No. resistor value needs to be a lot smaller with this setup. I'm definitely missing something. I'm going to have a little bit of a think about this. Maybe I want my LED on the other side. Oh, what am I doing? Alright, I think I've worked out what I've done wrong. My resistor needs to go to the output of this circuit here. So let's try that. Certainly makes it light up, but the amp does not work. I am so confused. So it wasn't the ground reference thing. It wasn't that. That was not the problem. So I can set this back up with a nice smooth reference. How I want it. That was not the cause of the problem. Although what I just gave it there was even more positive in respect to the rest of the circuit, so maybe it was that. But I mean, as you can see, it doesn't matter. I find it interesting that you know what? What if I used a JFET? Go through all my JFETs. Oh, they're probably only like 30 volts, but aren't they? Yeah. I'm trying to think of something I can use as a 2-terminal current sink that doesn't have a positive reference to it. So it's the same thing as having a resistor here, but a variable resistor that opens and closes to make sure that the current flow is consistent. That's the fix for this. Certainly my stiff capacitive multiplier cleans up the collector, the sub rail fixes things, but I'm still stuck in this one little section. Alright, I'm going to put this circuit to the side and start looking at 2-terminal devices or circuits that I can build a 2-terminal that don't rely on taking a reference from somewhere positive or 0 volt, which is positive in reference to the negative rail where this needs to go to, because it seems like that's what the problem is. I can't see how it's the actual current source itself, because I mean, I can put any value of resistor there between that and a negative rail, right? It's completely open. It's working fine. I could probably short it to the negative rail and nothing would really happen, I don't think, because the transistors barely got current flowing through it. But I mean, like, 2K2 resistor straight to the rail doesn't do anything. You know, let's grab something ridiculously small that's not too small, it's going to fry it, but 560 ohm. You know, it works the best. It doesn't get hot either. That's interesting, because you remember when I had the current source in the collector path and I put a 470 ohm resistor down here, it really cleaned things up in terms of the symmetry. Maybe I should put the 470 in there. But I'm worried with having no current limit and 470 ohm, how much current that transistor is going to dump between its collector and emitter into this rail when it swings. I mean, that's why I ideally want something to limit the current, but I can't put it in the collector path. I don't know, man. This is an interesting one. I really want to be able to control this transistor somehow, either via its collector or emitter, but you can't do it with the collector. You can clean the supply up, but you can't limit the current there. I mean, you can, but yeah. Let me go see what I can dig up on 2-terminal current limiting devices and circuits. Alright, here's what I think. We're going to have to run 2 tests. One, with the capacitive multiplier modified circuit in the collector, so it's got the clean collector supply, but we'll put the 470 ohm resistor direct to the negative rail. Still have the sub rail, right, because that provides not just this RC filtering, but the clean sub rail, so I don't need to worry about all my trying to get rejection in the emitter paths if I've got my sub rail that's smoothed and cleaned, right? And my collector's clean. So that's all the noise injection problems taken care of. So can I just put the 470 ohm resistor in there? Let's see how that will work. The other thing I thought of, I'll just get the picture up on my computer because it will make more sense. In the LM2907, in the VAS stage, we see that we have a PNP transistor here. Still just connected single end, there's no double end stuff going on. Single end, it would be on mine connected to this side because I've got the 4 transistor current mirror. But what I'm wondering, what if I eliminate this transistor, right? And move this to here, then I can have my current source from the 0 volt rail to the emitter of this. Its collector will be going to my clean sub rail, and then I can still put my Miller cap between here and here, bearing in mind that this won't be here. This base will just go to this emitter collector point of my current source, which will be the AC swing point then. I'd like to get some feedback on this, because it seems like those are the 2 options. Basically, well, there is a third option too. I thought about this. I could go back and put the current source in the collector, because I did a bit of reading on this, and some people reckon even up to like 4.7K, they're not noticing any phase problems, Miller effect problems, turning the collector of this into an AC amplifier. I don't really believe that, but we could always test, put the 470 ohm resistor in, current source in the collector. So I think that's what I'm going to do. I'm going to run at least 2 tests, one with the 470 ohm resistor here and this circuit here on the collector. See what that looks like. Crank up the swing and see if this transistor starts warming up or getting too hot with the 470 ohm emitter resistor, and see how the signal looks. And then I guess try it with the current source in the collector. Well, actually, I think what I'll do is I'll try it with the 470 ohm emitter resistor first, and this circuit here, see how that behaves. Then I'll take this transistor out and replace it for a PNP like in the LMT907, and put my current source back in the top, and see what that does. And last but not least, if I still think it's worth checking it out, I'll put the NPN back in, current source in the top, 470 ohm resistor in the bottom, sub rail, and I guess we can just measure the performance of all three. What I need to do is I need to work out, I'm imagining it would be like a frequency response test, you know, like do a sweep over frequency range and plot the amplitude of the output of the amp. I need to work out what the varying Miller effect is going to show up as, and then we can try these three different arrangements and see if, you know, the one where we've got the NPN transistor with the current source in the collector, if that actually does muck things up or not. So I really want to get feedback on this. I'm going to end this video here because I'm done trying to make circuits. I've designed everything I could think of. Current sources, current sinks, this circuit. I've worked out the lower value resistor here is better, the sub rail. Now I think what I'm up to doing is just literally running tests with all these different ideas. So that's what the next video will be. It'll be, you know, trying this circuit with the 470 ohm resistor and the sub rail. It'll be trying this removed and replaced with a current source, a PNP transistor, and we have to work out the rest. Actually, that doesn't have an emitter resistor, does it? No, its collector goes straight to the rail. I might put something small there, who knows? Probably not. Yeah, I'll probably put 100 ohms there, just to stop high frequency oscillation from being able to happen. But yeah, that's what I'm going to do. I'm done researching, I'm done playing around with circuits. I think there isn't really anything else that can be done with this. You know, I mean, obviously you can add a tracking transistor and a Baker clamp. That's the other two things. But like I said, I wanted to see what I could come up with. I've come up with what I can come up with. So the next video is just going to be running a signal through the amp and trying out these different circuits. So thank you everyone for watching, and please leave your feedback down below. I'm really curious to get feedback on this. Thanks for watching. I'll see you all soon.